Hello there, Mr. Wilson here again for what is part two of going through this sort of lesson revision style format on matrices. Now, just before we get started, if you haven't already, definitely subscribe and check out all the other videos on the channel. So we're going to carry on these revision lessons on matrices specifically for GCSE further maths. And in this part, we're going to talk about matrix operations. So, kind of when you have two matrices and you want to add or subtract them and things like that, or even multiply two of them together, how does that kind of work? So, we're going to look at that now. So, let's start with addition then and subtraction. Well, addition and subtraction are actually quite easy, right? So, when you have two matrices that are of the same dimensions, right? So, when you have two matrices like this, and you want to add them together, well, you just add the numbers in the same, well, add the elements in the same position together. So in this case, we're going to have a 3 by 3 matrix as our final answer, and the top left number is going to be 3, then it's going to be 6, and then 4, and then it's going to be 2, 4, 5, because I'm just adding the same numbers that are in the same positions as each other, and then the bottom row is going to be 2, 3, 9, and that's the final answer. So it's pretty much exactly the same as adding vectors, right? Because vectors are technically matrices, but a very special type. It's the same as adding vectors. You just add the numbers that are in the same positions. And if we go on to subtraction here, well, it is the exact same process. We just subtract the numbers that are in the same position. So 9 take away 3 is going to give us 6, and then 2 take away 1 is 1, 4 take away 7 is -3, and 8 take away 2 is 6, and then on to the bottom row, so we get 1, -1, 3, and 1. Now, I'm using curly brackets. I personally use square brackets, but since the other question has curvy brackets, I'm going to use curvy brackets as well. So that's the kind of really basic operation. Addition and subtraction is basically just the same as if it was a vector, right? You just add the elements, as we call them, that are in the same position as each other. So what happens then if we multiply a number by a matrix? Well, again, this is exactly the same as if it was a vector. You multiply the scalar multiple, we call this the scalar multiple, the whole number, by every single number inside the matrix, and it stays in its same position. So here we do 3 times 1, which is 3, and then 3 times 4, which is 12, and then 3 times 2, which is 6, 3 times 0, which is 0, 3 times 2, which is 6, and so on. We just multiply every single number by 3, and we get something that looks like this. So that is how you would multiply that scalar multiple. Now I'll give you a moment to think about how the bottom one is going to work when it's a half. It's the same principle, so I'll give you a moment to think about that one. So for this one then, we just literally half, because the scalar multiple is a half every number in the matrix. So we get 4.5, or you can even have a fraction, 9 over 2. 1, 2, 4 on the top row, and then we get 1, 2, 3, 0.5 on the bottom row. So we just half every number that's in the matrix. So multiplying by a scalar multiple and adding and subtracting matrices, that's quite sort of simple, really. There have been some questions though where you have to find missing values, so let me show you one of those. So now technically this is a vector, but a vector is a special type of matrix, as we've already talked about, and this is from a past AQA paper. This was from the GCSE Further Maths June 2016 paper 1 question 2. So we can use the ideas that we've just talked about there, but this time we've got to work out missing values. Okay, so we multiply the scalar multiple by the matrix, vector in this case, so we get 4 minus 8a over 4a is equal to b 12. And then what you get is, if you just read the top line of any matrix, right, and the bottom line of any matrix, you can actually form, well, in vectors you can, because it's just 1 by 2. But if you read the top line, you read the bottom line, you can form two equations. You get the equation 4 take away 8a is equal to b, and you get the equation 4a is equal to 12. Well, this one here is interesting, because if 4a is equal to 12, you can just divide by 4, right? So a must be 3. And then by looking at this first equation, so if the first one, this is the second one, by looking at the first equation, if we know a is 3, then 4 take away 8 times 3, which is 24, must equal b. So b is equal to negative 20. So actually you can work out unknown values using the idea that we've just talked about. But when it's sort of vectors and scalar multiples, that tends to be okay. It's when we are multiplying matrices with each other, that's when it starts to get tricky. So, multiplying a matrix by a matrix then. When you are multiplying by a matrix with a, and as it says there, this is where it gets interesting. When you multiply a matrix by another matrix, you need to multiply every element in the row of the left-hand matrix with every element in the right-hand matrix column, right? That means you can only multiply matrices if the number of columns in the left-hand matrix is equal to the number of rows in the right-hand one, right? So this is quite an interesting idea. So this is a 2 by 2 matrix, right? And this is a 2 by 1 matrix. Now, we are perfectly okay multiplying these matrices together because the number of columns, which is this number here, is equal to the number of rows in this one, which is this number here. So if these two numbers match, then we can multiply these matrices together. So just before we actually multiply these together, I just want to very quickly talk more about this idea of making sure that the dimensions are right, because if the dimensions are not right, you won't be able to multiply them together. So let me just find the question I was looking at. So let's have a look at these matrices then. So basically I'm wanting to multiply this pair together. So a 2 by 3, we're calling it matrix A, by a 3 by 4. So first thing you have to do is obviously check that you can multiply them together, because you can only multiply them if the number of columns in the left-hand one is equal to the number of rows in the right. So basically you have to check, is this dimension equal to this one? And it is. So we can multiply them, so that's okay. We can multiply these. The answer is going to be kind of what's left over here. So the answer is going to be a 2 by 4 matrix, right? Because there's 2 and 4 there. So the answer is a 2 by 4 matrix, meaning it has 2 rows and 4 columns, right? So it's going to have 8 numbers in it. Let's have a look at this one then. Well, the number of rows in this one does not match the number of columns in this one, so you can't multiply them. Therefore, there's not any answer here. We just can't multiply these together. And there have actually been a few questions that I've seen on the GCSE Further Maths where you have to state why you can't multiply two matrices together. And again, it's because the number of columns in the left-hand matrix doesn't match the number of rows in the right-hand matrix. Okay, this one does match though, so we can multiply these together, and the answer is going to be a 4 by 2 matrix, meaning it has 4 rows with 2 columns. And again, these two match, so we can multiply these together, and the answer is going to be a 1 by 1 matrix, or just a number, right, in this one, which is quite interesting. So you've got 1 row, 3 columns, 3 rows, 1 column, and the answer is just going to be a number, which is quite an interesting idea. So please make sure that you check the dimensions, because you never know, right? They might throw a bit of a red herring in there, and it is absolutely essential that we know that these numbers should match in order to be able to multiply them together. That is a key idea. So back to our question that I was going to do then. Well, we know that we can multiply them together, that's okay. And we also know now that my final answer is going to be a 2 by 1 matrix. In other words, it's going to have 2 rows right? It's going to have 2 rows and 1 column, so it's actually going to be the same as this one here, right? It's going to have 2 numbers on top of each other like that. Now, to multiply these together, what you need to work out is you need to multiply every element in one row of this matrix with every element in the column of this matrix and add them together. So in other words, you do 3 times 0, which is 0, plus 2 times 3, which is 6. So this top number is going to be 6. And then you do 3 times, so for the bottom number you do 3 times 0, which is 0, plus 0 times 3, which is 0. So the bottom number is going to be 0. So the answer is 6, 0. So I multiplied every element in a row with every element in the column of the other one. That's why the columns need to match the rows, because otherwise you just won't be able to do this kind of method. So going across and then going down on this one, and you add the 2 numbers together in this case to get each of these. So 6, 0. Can I just point out that this takes a lot of practice? It's not something that just happens overnight. It's not just like you do one question, you think, oh yeah, I'll get that. Matrix multiplication tends to be one of the most difficult ideas. Not because the maths is difficult, you're just multiplying numbers, aren't you? It's because the order and the way you do it confuses a lot of students. So through practice, that's how it's going to make sense. But basically, you go across on this one and down on this one. Let's have a look then at a slightly trickier one, and then I'm going to sort of give a couple of questions to have a go at. So this one is slightly trickier then, because it's a 2 by 2, right? So 2 by 2 matrix multiplied by 2 by 2 matrix. And again, just a quick check. Can we multiply them together? Yeah, of course we can, because these 2 numbers are the same. And what we're left with is 2 by 2. So my answer is actually also going to be a 2 by 2 matrix. So if you multiply a 2 by 2 with a 2 by 2, you get 2 by 2. And this actually applies to any square matrix. If you multiply a square matrix by a matrix of the same dimensions, then you get a matrix of the same dimensions as the answer. So to work out this one, you need to multiply every element in the row of the left-hand one with every element in the column of the right one. So you do 4 times 1, right, which is equal to 4. So I'm working out this number here. I'm going to put like a red box here. So I do 4 times 1, which is 4, plus, I'm going to cross on this one, so 0 times 4, go down on this one, which is 0. Add these 2 together. My answer is 4. Okay, then I need to work out this one here. To work out this one, you start on this number for this one, but you still start on this one. So 4 times 2 is 8, and then you go across on this left one and down on this one. So 4 times 2 is 8, plus 0 times 1, which is 0. So you get 8 for this top right one. Okay, let's turn to this one down here. So to work out this one, you're now on this bottom row here, because we've done the 2 for the top row, so we now start on the bottom row. We do 1 times 1, which is 1, plus you go across on this one and then down on this one. 2 times 4, which is 8, and that's going to give me 9. So 9 goes in that one. And then finally, we need to work out what this one is in this black box. So you do 1 times 2, which is 2, plus 2 times 1, which is also 2. The answer is 4. So the correct answer is 4, 8, 9, 4, reading across on that matrix. And again, this takes a hell of a lot of practice. But the general form is, and I'll give you the sort of general form for this. If you want to multiply a matrix A, B, C, D, and this is very common at GCSE further maths, 2 by 2 multiplied by 2 by 2, A, B, C, D by E, F, G, H, okay? Then the answer is going to be AE plus BG, and then it's going to be this top right one here is going to be AF plus BH. This bottom left one is going to be CE plus DJ G, and then this last one is going to be CF plus dh, like that. So basically you get every single element multiplied with every single other element, but that is the general form for a 2 by 2 multiplied by another 2 by 2. That is the general form and how you do it. Now, I always say to my students, oh, you just move this finger across and this finger goes down when you multiply them. And none of my students understand anything of what I mean. But that was the way I was taught. Actually, I taught myself GCSE further maths. I didn't have lessons on it, so I taught myself how to multiply matrices, and that was the technique I came up with to multiply them. So if you want to multiply, you start with the fingers in the right position, and then you multiply them together, and then you move this one across, and then this one goes down, and then you multiply those together and add them together. That's just the system that I've always sort of lived by, to try and multiply 2 by 2s with other 2 by 2s. Okay, let me just give you a couple of questions to have a go at, and then we'll sort of wrap it up there for this part. Okay, so I've just plucked these matrices off the web, but then I've sort of written my own questions here. So given these two matrices, so we've got 4, 1, 0, 2, and we've got 3, 1, 2, 0, work out AB, which means you do A and B, and then you times them together. Work out BA, and then work out IA, where, and I feel like my head's covering it up a little bit. Am I going the wrong way? This way? Where I is the 2 by 2 identity matrix. So remember, the identity matrix, if you are unsure, we talked about in the previous part, for 2 by 2, it's 1, 0, 0, 1. It has ones down the leading diagonal and then zeros in every other position. So I want you to have a go at these, because there are two key talking points about these questions that I want to discuss. So pause the video now, because I'm not going to wait several minutes of me just in silence. So pause the video now, and then we'll go through the answers in a second. So hopefully you've had a chance to work out these questions. Let's go through them. So AB means A goes on the left, and then B goes on the right, like this, and then you multiply them together. So you get 4 times 3, which is 12, plus 1 times 2, which is 14 altogether. Then the next one, this top right one, we do 4 times 1, which is 4, plus 1 times 0, which is 0, so we get 4 for this one. Then we do 0 times 3, which is 0, plus 2 times 2, which is 4. So we get 4 for this one. And then we do 0 times 1, which is 0, plus 2 times 0, which is also 0. So we get 0 for this last number here. So the correct answer is 14440. Wow, that was a bit of a tongue twister, wasn't it? So that's what hopefully you should have got. Please let me know if you got that answer in the comments below. Then, BA means basically the same matrices, but in the reverse order. So 3, 1, 2, 0, and then 4, 1, 0, 2. So 3 times 4, which is 12, plus 1 times 0, which is 0, so that's going to give us 12. Then 3 times 1, which is 3, plus 1 times 2, which is 2, so 3 plus 2 is 5. 2 times 4 is 8, plus 0 times 0, which is 0, so that's just going to be 8. 2 times 1 is 2, plus 0 times 2, which is 0, so that's just going to be 2. Now, this is the first talking point. What do you notice about these answers, which is super weird? So the fact is we've changed the order, but they're different answers, but they're the same matrices. So we were multiplying them together, and all we did was we changed the order around. We've got a completely different answer. And actually, this is meant to happen. The fact is that matrix multiplication is what we refer to as associative, right? I'll explain what that means in a second, but not commutative, right? So the order of a matrix multiplication matters, right? That's why when you do a question in your GCSE further maths, you should be really careful about what order you put them in. So if it asks for AB, it wants it in that order. And if you change the order, you get a completely different answer. So the order of the matrix matters. So let me talk about these two words then, if you've never heard of these. So associative, it's actually one of the fundamental sort of rules in maths, right? When you get to a high level, you talk about like groups. Associativity is being part of a group. So associativity is the idea that if you do A times B times C, right, you could either multiply A and B first, then multiply by C, and that is exactly the same, right, as if you multiplied B and C first, then you multiplied it by A, right, with B and C on the end. So you haven't changed the order, you haven't changed them around, you've just changed the order in which you've multiplied them. You haven't actually changed the position of the numbers, is a better way of phrasing it, but what you've done is you've basically said, oh, I'll multiply these two first, then multiply by the last one, or you multiply the last two, then you multiply by the first one. But you haven't changed the order of the position of the numbers, you've just changed the order in which you're doing the operation. So matrix multiplication is associative, right? If you have three matrices, and you want to multiply them together, it does not matter if you multiply the first two, then multiply the last, or you multiply the last two, then the first. As long as you don't change their position, you'll get the same answer. Commutativity, on the other hand, right, is a much stronger rule in maths. By stronger, I mean not everything. Things can be associative but not commutative. Like in this case, commutativity means if you do A times B, then that is mathematically the same as doing B times A. Now, this applies to normal multiplication because obviously things like 3 times 4 is the same as 4 times 3, right? They are mathematically the same thing, right? Because multiplication in normal numbers is commutative. So is addition. I mean, division and subtraction is not, but for multiplication and addition of normal numbers, they are commutative, which then means it's super weird that when you do multiplication, which is commutative for normal numbers, or matrices, it's not commutative anymore. So that's the kind of idea. We have to be really careful about the order, because A times B is not the same as B times A for matrices. And obviously, as it says there, don't forget to check to see if the dimensions are correct. Okay, then let's have a look at this last one then. Let me just scroll down a little bit. So IA, where I is the 2 by 2 identity matrix. So 1, 0, 0, 1 times the matrix A, which was 4, 1, 0, 2. So we do 1 times 4, which is 4, plus 0 times 0, which is still 4. Then we do 1 times 1, which is 1, plus 0 times 2, which is 0. So we get 1. 0 times 4 is 0, plus 1 times 0, which is 0. And then 0 times 1, which is 0, plus 1 times 2, which is 2. Wow, that's super weird. Because what we've ended up getting here is the same as what we started with. This is matrix A. So what is the deal with the identity matrix then? Well, the identity matrix has a very special purpose in life, right? Is that when you do the identity matrix multiplied by any other matrix, you get the same matrix back again. It's almost like in maths when you multiply by 1, right? That sort of famous rule that if you multiply anything by 1, you get itself, right? This same idea applies to matrices. This is just the matrix equivalent of the number 1, right? If you do the identity times A, you get the same matrix back. And actually, you can reverse the order for this because it doesn't matter whether the identity matrix comes second, you still get A back. So this is the very rare case where actually the order doesn't matter, but in every other matrix multiplication, it's non-commutative and the order matters. But in this very rare instance, when you've got the identity matrix, it can be done in either order. But it doesn't make matrix multiplication commutative just because it works for one case. But that is the sort of deal with the identity matrix, and it's a very, very useful idea when you get further on into maths and you talk about inverse matrices and you talk about discriminants and all this other fun stuff in life. You realise that like a matrix multiplied by its inverse gives the identity matrix. So the identity matrix comes up so often at sort of high level maths, and is a very, very useful thing to know. So For its purpose in GCSE further maths, there's actually a slight second purpose it has, but that is for the next part. For our purpose, if you multiply anything by any matrix by its identity, then you get the same matrix back again, which is quite an interesting idea. So I'm going to leave it there for this part because I feel like I've ranted on way too long with this. I would highly recommend searching online and just practicing loads of questions. I actually might do a part where I just write loads of questions and sort of get you to practice them, then I'll talk through them. But really the best way to practice matrix multiplication is through the practice, is through repetition, because it's not the maths that's difficult, right? The multiplying the numbers is not difficult. What is difficult about these questions is the order in which you perform the multiplications and when you are adding them together, and also just trying to catch the idea when you can't multiply matrices because the dimensions are not right. All this, that is what confuses a lot of students. But I think it's just because something like this is so new to a lot of students, especially when you see it at GCSE further maths, you think, oh, it doesn't really make any sense. But I've worn that t-shirt and I can say wholeheartedly it does make sense eventually, just through that practice. So if you are still struggling with these, I would highly recommend just googling GCSE further maths matrix questions, just having a little practice of loads of those, and just getting more used to that. But hopefully this video has offered you a little bit of insight and a little bit of a reminder on how we multiply matrices. So just as a recap then, in this session we looked at multiplying matrices, we looked at the power that the identity matrix has, and we also looked at the idea that matrix multiplication is non-commutative, so the order matters. So in the next part we're going to look at matrix transformations, which tends to be, again, a very difficult topic for a lot of students studying GCSE further maths, and we'll look at the different kinds of transformations that can occur. This might be over a couple of parts actually, and then we might finish off with some more exam style questions on matrices and sort of talk through those. But if you've stayed all the way to the end, I mean, congratulations, it's been half an hour of me ranting about matrices, so very, very well done to you if you've stuck right to the end. Let me know in the comments if you have stuck right to the end. But all I want to say is thank you so much for watching, and I hope you have a fantastic day.